Welcome. In the current video, the process of performing a duty cycle analysis of the shock tower of a car over time will be followed. 2 unit forces and 1 moment are exerted at the end of the rail and 2 other unit forces on the strut tower. They are resolved in 2 different events. The phenomenon will be studied in the time domain. To begin with, a new task is created, in which the model is loaded. For this action there are 2 ways. The user can load either the geometry or the results file. For this case, the results file is loaded. The next step is to set up the material for our model. Access the material database, select Steel 1005 and Steel 1008 from the internal material database and press the arrow to transfer them in the session materials list. Switch to Assign Materials. The user can define special rules which filter the model entities and apply the correct material automatically. Select the button New Rule to make 2 rules, based on thickness, for the assignment of the materials. Create the rule Thin, for thicknesses under 1. Select Steel 1008 and press OK. Many rules can be put in use together to complete the material assignment. Create the second rule Thick, for thicknesses in a range from 1 to 1.5. Select Steel 1005 and press OK. The materials will be automatically assigned to the respective PIDs. Moving forward, go to the Analysis Configurator window so as to fill in the necessary analysis parameters. The current analysis is a stress-based fatigue analysis, using the uniaxial method in the time domain. The input results are static and will be multiplied by time history force signals in order to obtain the cyclic stresses. Generally, this process is linear and Gaussian. Choose Rainflow algorithm to count the fatigue cycles and determine the damage from Miner's rule. No mean stress correction will be used here. The evaluation will be for the signed max principal stresses on the element corner for both top and bottom shell layers. The next important move is to define the loads, so access the loads database. In the present session, the 5 time histories will be loaded as curves from a file by pressing the Import button. Each curve has 1000 points with a time increment of 1 second. Then, switch to Assign Loads to assign the time history to the static subcases. Select the first box, Event 1 of Channel 1, and press the Time Series button. Select the option Create Parallel Channels and combine the subcases 4 and 5 with the respective curves. The next phase is to follow the same procedure for the second independent event. Select the box, Event 2 of Channel 1, and press the Time Series button. Select the option Create Parallel Channels and combine the subcases 1, 2, and 3 with the respective curves. Subsequently, the scenario has 2 events. The fatigue calculation is done per event. Finally, the user can optionally specify an output path in order to save the MetaDB with the results that will be output. Move to the field Select Entities to calculate. With the option all entities participate in the analysis. Moreover, the analysis can be focused only on the visible entities or on certain entities based on parts, PIDs, MIDs, sets, or fatigue material. For the current scenario, the option Manual from fatigue material will be chosen. Select the 2 materials and run the analysis. Once the analysis is completed, the results can be displayed through the dedicated plots of fatigue. In the Plot Properties area, through Fatigue Analysis Type, results such as damage, life in repeats, life in seconds, log of damage and log of life can be viewed. In the current scenario, the results can be viewed for every event separately and also for the total duty cycle process. Furthermore, it is easy to define annotation on worst element with detailed information. Switch to Post tab, press the Time Series button. The input stress signals and the stress derived from linear superposition will be displayed, by default for the worst element and worst node. Choose the events plot for an overview of the damage and life of all events as bar charts, as well as a total life and damage bar. A bar for every event is displayed. Select the option Worst per event to see the worst element per event. All 2D plots have a direct interaction with the model. So, by modifying the parameters, the plots are updated. For example, more than one element can be chosen by the user with the option Pick. Directly the results are displayed on the selected plot. Another capability is the rainflow matrix. Each identified cycle has a mean and amplitude value. Z-axis can be the number of cycles or the cumulative damage of the cycles that belong to this bin.